Hello, student of class 10. Now we are going to start exercise 6.4. I'm going to start from question number 5. This is the proof, which is very important for your coming matric exam. These proofs are very important. Now first, NCR plus n minus 1 CR minus 1 plus n minus 1 CR minus 2 is equal to n plus 1 CR. You have to prove this. Now, while proving this statement, we have to use the theorem 2. We have to use the theorem 2. Here we have to use the theorem 2, which is NCR plus NCR minus 1 is equal to n plus 1 CR. We have to use this theorem number 2, which is given in your book. Now, by the help of this theorem, we can very easily prove this above statement. That is from left-hand side. Left-hand side, NCR plus n minus 1 CR minus 1 plus n minus 1 CR minus 2. Now, if you compare these two with the formula, if you compare these two with the formula, what do you find? So, see, here n, so n minus 1, n minus 1. Now, here this is r minus 1, this is the next term. This is 1 less than r. Now, same thing is happening here, r minus 1. The next term is 1 less than the first term. So now we can apply this formula. So when we apply this formula, this will become like this, NCR plus C, n, one number is get added to n, therefore 1 will be added to here. Therefore, when n minus 1 plus 1, it becomes n. And now, of this r and r minus 1, the greater number is selected. Now, r minus 1 and r minus 2, greater is r minus 1. So, r minus 1 will be selected. This is done. Again, we will apply theorem 2. Again, I am going to apply theorem 2. You see, this is theorem 2 and it is the same. So, your answer will be n plus 1 CR, that is equal to right hand side. Proved. I think so it is clear to it is a very easy because only theorem 2 which is given on your book and theorem 2 has been utilized to solve this problem. Here this is the theorem I have written here. Now here this is the left hand side. You compare this and the theorem. See n and here these both are the same. Here n minus 1, n minus 1, both are the same. Now, this is r and the second term is 1 less than the first. So again here, this is r minus 1, the second is 1 less. Both are same. And the result is n plus 1, 1 is added to n and the greater of these two are selected. So this 1 is added to here n minus 1 plus 1, it becomes n. And the greater of these two is selected, which is r minus 1. Again, you see this is theorem 2, we get the answer. Now, again, I am going to prove the second question. The second question you will... this is also very easy. It is not tough. You will find it very easy. Here the second question. That is NCR minus 1 plus 2 NCR minus 2 plus n CR minus 3 is equal to n plus 2 CR minus 1. Again, we will take the help of this theorem 2. This is a very important theorem. This theorem 2, NCR plus n CR minus 1, that is equal to n plus 1 CR. We are going to take the help of this theorem 2. This is theorem 2. We are going to take the help of it. Now, we will write the left-hand side. Your left-hand side is NCR minus 1 plus 2 NCR minus 2 plus NCR minus 3. Now, you can write it like this, NCR minus 1. Here, this is 2. Therefore, NCR minus 2. Again, plus NCR minus 2 plus NCR minus 3. You can write this like this. Now we are going to take the help of this theorem 2. When we are going to take the help of theorem 2, you compare this and this. See, n, here also n. Now this is r, and the second term is 1 less than the first. Here this is r minus 1, this is r minus 2, 1 less than the first term. We will apply this law, this theorem. So n will become to n plus 1. And of these two, we are taking the greater one, that is r. And of these two, we are going to take the greater one, that is r minus 1. Similarly, here, we will apply the theorem 2. You see n, both is n. Now, r minus 1, see r minus 2. This second term is less than 1 less than the first. So again, theorem 2, we are going to apply the theorem 2. It will become n plus 1, c. The greater of these two is r. Here the greater of these two is r minus 2. Now again we are going to apply the theorem 2. Here you can see n plus 1, n plus 1. These are the same, n plus 1. Now the second is 1 less than the first. We are going to apply the theorem 2 again. So the result will come to out will be, this is plus 1 will be added to n. Here n plus 1 plus 1, which will become n plus 2. And c, the greater of this is r minus 1. See, it is the right hand side. Let's see. So you will find that by applying this theorem, it becomes very easy to you to prove all the statements. Now I am going to, I am going to this question number 3 proof. This is also a proof. I am going to question number 3. That is, this is also a proof. Now you will find that your proof you will find. It's also very easy. The third, it is a NCR is to NCR minus 1 is equal to n minus r plus 1 is to r, and r is less than equal to n. Means you must remember that in the formula NCR, this NCR is r. This r is always less than or equal to 1. R cannot be greater than n. R is always less than equal to n. So this condition has been written here in the question. Now I am going to solve it from left hand side. NCR by NCR minus 1. This is the left hand side. Your NCR, which will be equal to n factorial by r factorial by n minus r factorial. Now, and this is, and the denominator, which is n factorial by r minus 1 factorial, again n minus bracket r minus 1 factorial. Now it will be as you know, it will be get inverted, and when the denominator will get inverted, means this into r minus 1 factorial, n minus bracket r minus 1, this whole factorial divided by n factorial. Now this n factorial cancels out. Again, 1 by r factorial, the next term will be r minus 1 factorial. The next term will be r minus 1 factorial. N minus r factorial, this is n minus r factorial, into r minus 1 factorial. And the next term of this n minus r minus 1, and the next term will be n minus r factorial. So there is no denominator, that means 1. You find that r minus 1 factorial, r minus 1 cancels out, and n minus r factorial and n minus r factorial cancels out, and the remaining is this n minus r minus 1 by r, which is equal to n minus r plus 1 by r. See, this is equal to right hand side. This is right hand side. The proof is very easy, but one thing you must all remember here, one thing you must remember, that is you have n factorial, this is equal to n minus 1, n minus 2, n minus 3, ... 3, 2, 1. What do we find here? We find that if you increase 1 in the second term, the whole result reduces by 1. That means if you increase the second term, this is the second term. If you increase the second term by 1, that means you are increasing the second term by 1. This whole get reduced by 1. That means this whole will become less than this. This whole will become less than this. That means n minus 1, this is, if you increase the second term by 1, if you increase the second term by 1, that means it will become n minus 1 plus 1. You are increasing the second term by 1. The whole, this whole will become 1 less than this. This whole will become 1 less than this. This is very important. This is very important. You must remember that when you increase 1 in the second term, here I have increased 1 in the second term, this whole becomes 1 less than this term. This whole becomes 1 less than this term. So here, n minus r minus 1, the factorial, here in this is the second term. This is second term, we are increasing by 1. That means n minus, we are increasing by 1. N minus 1 plus 1. We are increasing by 1. This whole becomes 1 less than the above. This whole will become 1 less than the above. Therefore, n minus r minus 1 factorial, n minus r, the next term of this will be, see here, minus 1 plus 1 cancels out, only n minus 1 remains. N minus 1 factorial remains. So here, n minus r minus 1 bracket factorial, the next term of this will be n minus r factorial. This is very important. You must remember that if we increase 1 in the second term, the result, if we increase 1 in the second term, the result, this is, we are increasing 1 in the second term, the result, the whole result becomes 1 less than this number from the first term. This is very important. So n minus r minus 1, the whole factorial, of this we are increasing by 1. When I increase by 1, this whole becomes 1 less than this earlier term. So after this, the next term will be n minus r factorial. Now I think so it is okay, everything you have learned it, and I think so it is very easy. Only the important thing in the factorial, that is, you must know what must be the second term. What must be, if it is 5 factorial, then after 5, what becomes the second term? The second term will be 4 factorial. This is the main theory you must, this is the main theory of factorial. Now I am going to the another proof. There is one more proof. 2 proofs are left here. So I am going to the proof now. That is NCR is equal to n by r into n minus 1 CR minus 1. Here I will move from the right hand side. Because from the right hand side it becomes easy for me to prove it. Because from the right hand side it becomes easy for me to prove it. That is NCR into n minus 1 CR minus 1, that is equal to n by r. This is n minus 1 factorial by r minus 1 factorial by n minus 1 minus bracket r minus 1 factorial. Everything is clear to you now. N by r into n minus 1 factorial divided by your r minus 1 factorial, and here n minus 1 minus r plus 1 factorial, minus 1 and plus 1 cancels out. Now here you will see that n minus 1 factorial, now denominator r minus 1 factorial, and here minus 1 cancels out, the remaining is n minus r factorial. Now this will become n factorial and this will become r factorial. And here, this is n minus r factorial. And this is, we can write it as NCR, which is equal to right hand side. That means you must know that 5 into 4 factorial, that means we can write as 5 factorial. Similarly, n into n minus 1 factorial, we can write as n factorial. 3 into 2 factorial, we can write it as 3 factorial. So this is the theory which has been applied here. And you see, it is very easy. The proof is very easy. It's very easy. Now I am going to the second question. that this is also a proof, which is the last proof. I'm going to the last. R minus 2 into n minus 2 C R minus 2 is equal to n minus 2 into n minus 3 C R minus 3. Now here I will start from the left hand side. We can move from both the side, but I will start from the left hand side. That is R minus 2 into n minus 2 C R minus 2. Now r minus 2, that is n minus 2 factorial by r minus 2 factorial by n minus 2 minus bracket r minus 2 factorial. Now here one thing is that now you see that r minus 2 into n minus 2, the next term will be n minus 3 factorial. The next term will be n minus 3 factorial. Again here, r minus 2, the next term will be r minus 3 factorial. And here we will open the back bracket, n minus 2 minus r plus 2. This is now when we open it, here this 2 and 2 cancels out. This is equal to, you have to write equal to r minus 2. Now here one thing for this is better that we cancel out this r minus 2 and r minus 2. The remaining left will be n minus 2. This is the remaining left, and then n minus 3 factorial. This is n minus 3 factorial divided by, this is r minus 3 factorial. Now again here n minus r factorial is left here. This 2 minus 2 and plus 2 is cancelled out. Here we can make a slight arrangement. This arrangement has been done in order to bring n minus 1 C r minus 1. This arrangement has been done to bring n minus 3 C r minus 3. So what I will do here, this will remain like this factorial, then n minus r. Instead of here, what we'll do minus 3 plus r plus not plus. We will do one thing. I have to just arrangement will be like this. N minus 3, this minus bracket r minus 3. Yeah. Like this. Here you see I am doing the expansion of this will n minus 3 minus bracket r minus 3. This will be n minus 3 minus r plus 3. See, plus 3 minus 3 cancel out, n minus 3. See, this remains as n minus 1 factorial. So there is no effect if we add minus 3 and plus 3 here. There is no effect, that it remains the same. This is the light arrangement I have to make here in order to bring this. This is the light arrangement I have to make here. So n minus 2 and this whole part, this will become n minus 3 C r minus 3. This will become n minus 3 C r minus 3. This is equal to right hand side. This is the proof. Now this is all the proof I have given to you. Now we will move to question number 6. Question number 6 again. I think so it is clear, everything is clear to you. These proofs are very easy. It's not so tough. And now I am going to this question number 6. The question number 6, this is question number